everyone, in this video we're going to factor trinomials where the coefficient of x squared is not equal to 1. So here's an example. 3x squared plus 13x plus 4. So as you can see, there is a number in front of the x squared, and if this is not equal to 1, then we would have to use different method, and I'm going to go over two different methods. Number one is called the grouping method, and the second one is called the crisscross method. Okay, so method number one, grouping method. Okay, so first step, we're gonna have the product using the first number and the last number. So we're gonna call that product. 3 times 4, which is 12. Okay, and we're gonna call the middle number, which is the coefficient of the x term, sum, as positive 13. So what we're going to do is we're going to find the two numbers, make the product of 12, and those two numbers will be the sum of 13. So we're going to start with any two numbers make the product of 12, so we could do 2 times 6, 3 times 4, we could do 1 times 12, and we can even do 4 times 3, 6 times 2, and so on. Okay, so find the one that has the sum of 13. So this one makes the sum of 8. This one makes the sum of 7, so it won't be those two. That one makes the sum of 13 because 1 plus 12 is 13. So even without going through the last two, we found our two numbers. So once you get those two numbers, we're going to use these two, 1 and 12. We're going to rewrite this, the second or middle term using those two. So which means we're going to split the 13x into two terms using the 1 and 12. So it will be 3x squared plus 1x plus 12x and plus 4. So we started with the 3 terms. Now we have 4 terms. So now we're going to make groups of 2 terms. So this is the first group, and that's the second group. And we're going to try to find the GCF of each group. So 3x squared plus 1x, the common term or a common factor is just the x. And we're going to factor that out from the first two. So that will be 3x plus 1. Okay. And we're going to do the same thing for the second group. So 12x plus 4 has the GCF as 4, which means as 4 can divide both terms in the second group. So it will be 3x plus 1. So if you look at inside the brackets, it's actually not a coincidence that we have the same expression, 3x plus 1 and 3x plus 1. So that is actually a hint that says we are on the right track. So we're going to factor these two expressions inside the bracket as one factor, 3x plus 1. And then we're going to make a second set of brackets, and we're going to just write x and plus 4. So that's how you get the answer for trinomial factoring using the grouping method. So that's the answer. Okay. So a few notes that I want to mention. So note, when you're splitting the middle term through 13x, the order of writing these two terms 1x, and 12x, you can actually switch the order and you can write it as 3x squared plus 12x plus 1x plus 4. And you still get the same answer as 3x plus 1 and x plus 4. So here, the order does not matter. Okay. And another note that I want to mention is number 1 note. Number 2, when you have the numbers that you chose for the sum and product, if one of the numbers is 1, then it is better to write 1 as the coefficient of the x term. The reason is it's easier to do the factoring when you actually have the number 1 in front of the x term, so that way you don't make a mistake. For example, if you have 3x squared plus x and you're trying to factor out the common factor, and some people write as 3x and then that's it, but that's not the same thing as 3x plus 1 times x. So if you actually write a number in front of the x, then it's obvious that there has to be 1. The number 1 has to be added. So make sure you write 1 in front of the x just to be sure that you have the correct answer. Okay, so let's try the second method. So I'll start it on the new page. Example 2. Let's do 6x squared minus 17x plus 5. This time we're going to use the method called Criss-cross method. Okay, here's the second method using Criss-cross method. This is actually a quicker way to do the factoring. So the first step, we're going to pick two numbers that multiply to the first term. Okay, so here's the first term. So, and just to remind you guys, when you're doing trinomial factoring, make sure you have the trinomial written in descending order, which means you have to have the x squared term, and then x term, and then constant. So the exponents of each term has to decrease by a decreased, okay, not increasing or not a random order. So make sure you write in descending order. Okay, so note trinomial or trinomials must be written in descending order. Okay, so we've got 6 as the first term. So we're gonna pick two numbers that make the product of 6. Okay, and we will write those two numbers vertically. So 6 can be written as 2 times 3. So we can start with 2, 3 like that, and then we're gonna go to the last one. We've got 5, and pick two numbers that multiply to 5. Okay, so that could be 1 and 5. Okay, but there are other options, but we're going to try one at a time. So once you have those two sets of numbers, we're going to multiply sideways, which means we're going to do the crisscross like this. 3 times 1, that gives us 3. And 2 times 5, and that gives us 10. And then what we're going to do is we're going to try to add those two numbers, see if we get the middle term's coefficient. So add those two, and we have 13, which is not the same number as negative 17. So we have to have the negative 17 or 17. So it's not same. So that means we do not have the correct numbers. So we're going to try again. So maybe we can try switch the order of 1 and 5. So maybe we can try 2, 3, and 5, 1. And do the same process. So crisscross, 3 times 5, that's 15. 2 times 1, that's 2. And we're going to try to add those two numbers, and we've got 17. So we've got negative 17 that has to be sum, but we got 17, positive 17. But is there a way we can make the 17 to negative 17? Yes. So what we're going to do, we're going to put the negatives in front of the 5 and 1. And that changes it to negative 15 and negative 2. This makes the sum of negative 17, which is the same number as the coefficient of the middle term. So we got the correct numbers. So how do we write the answer? This makes one set of factor, and this makes another factor. Okay, but make sure you use the variable after 2 and 3. So here's the answer. So 2x, because you have to have the x squared at the answer, at the end, minus 5. So that's one set. And using the second row, 3x minus 1. And that's how you get the answer. Like always, you can check whether you got the right answers or not by distributing the factors. You get the original expression. Okay, so that's how we get the answer using crisscross method. Hi guys, in this video we're going to go over a special trinomial factoring. It's called difference of squares. So this is really quick and easy factoring method. So all you need to do is to recognize the squares in your expression. So usually the difference of squares happens when you have the two terms. So I'll give you an example. For example, x squared minus 9. Okay. Unlike the other trinomials, this one has only two terms. So we shouldn't call it trinomial, binomial. But the degree of the expression is 2. But it could be higher than 2. So how do we solve this? How do we factor this? You have to recognize that each term in this expression is in squared form. So this one is a square term because it's the x times x. It's a product of the same factor. The second one is also a square, which is 3 times 3. So what we're going to write is, as the answer or factored form is, we're going to use each factor from each term. So x, 3, x, and 3. But the first one, or the one factor, will take the sum, and the other one will take the negative or subtraction. So this is one way to write it, or if you like to write with the subtraction sign first, then you could also write it as x minus 3 and x plus 3. So order, in this case, the order doesn't really matter. Okay. Let's try another example using difference of squares. This time a squared b to the power of 4 minus 100. Okay. So as you can see, now the degree of the factor is not 2 anymore. So it could be higher than 2, but it has to be the even number degree, even number exponents. So just like the first example, let's take a look at each term. So a squared b to the power of 4 is ab squared times ab squared. How do we get this quickly? You can just try taking the square root sign of the term, which is ab squared. And 100 is obviously a square number, perfect square, so that would be 10 times 10. So the answer is ab squared plus 10, ab squared minus 10. Or if you like, you can write ab squared minus 10 ab squared plus 10. Okay, let's try a few more examples. This time it's 4x squared minus 25. So the first term, if you take the square root, 4x squared, it will be 2x. The second term, take the square root of 25, it's 5. So these are the terms that we're going to use in our brackets for the factored form of this expression. So it will be 2x plus 5, 1 with the addition. Same term, this time subtraction sign. So that's how you get the answer. Pretty easy, right? Let's try another one. Let's do 9x to the power of 6. Let's try the bigger expression, bigger exponents. Y to the power of 8. It's pretty big, but like I mentioned, the exponents, if the exponents are even number, then we're good to go. So, and also the number, also the coefficient. Okay, so this, you have to check the coefficients as well. So exponents must be even number, coefficients must be perfect square, unless they can be factored out before we try the difference of squares. So this is perfect square number, and these two are even numbers, then we're good. Okay, so let's take the square root of 9x to the power of 6, which is 3x to the power of 3, or 3x cubed. Okay, all you need to do is you just need to divide the 6, the original expression, exponents, by 2, then you will get the 3. So that's how you take the square root. And y to the power of 8, and take the square root, and that will be y to the power of 8 divided by 2, so that will be 4. Okay, so we got those two numbers, the terms. Then we can do two sets of brackets, and 3x cubed plus y to the power of 4, 3x cubed minus y to the power of 4. Okay, let's try one more. This one takes a little more steps, but this is also pretty simple once you understand the steps. Okay, last example. So we've got x to the power of 4 minus 1. The exponents that we have is the even number, so we're good to go. So let's try taking the square root, x to the power of 4, which is x squared. And let's try the 1, which is obviously 1. That's simple. So let's rewrite the expression as factored form, x squared plus 1 and x squared minus 1. Okay. So what do you think? Are we done? Actually, we're not actually done, because if you look at the second set of brackets, this one is actually another difference of squares, because x squared is the perfect square and 1 is also a perfect square. So we can do another factoring just for the second set. So let's do that over here. We're going to keep the first one the same, x squared plus 1. We're going to just try factoring the second one. So x squared is x, square root of x squared is x. Taking the square root of 1 is 1. So it will be x plus 1 and x minus 1. So the last example has 3 factors in the brackets. That's it. That's how you do the difference of squares. If you have any questions, please give us an email. Send us an email with the example questions, and we'll go over that next time. Thanks for watching.